To plunge freeze a specimen, what we would need is a freshly prepared tray with liquid ethane. We need glow discharged grit, also freshly prepared. We need a pair of Vitrobot tweezers. We need to have a lid on the storage box. The storage box is already present in the tray, and the lid with the corresponding tool to remove or to assemble that lid, or a tool which has the lid and the tool in one piece. And we need a pipette, a microliter pipette, 10 or 20 microliters set to 3 or 2.5 microliter for applying the specimen. The first thing we do when the Vitrobot is active, we have to set the humidity to 100%. It's already at 100%, but if it's not, we simply raise the humidity to 100% and switch from off to on. What you'll notice is that there will be water vapor blown in the chamber. I can set it to manual, and then you'll see what would happen to create 100%. So if we go back to on, it just regulates it, and it will only blow water vapor in the chamber when it's not at 100%. So now it's at 100% humidity. And you can also set the temperature to any desired temperature. Be aware that when the temperature, the real measured temperature, deviates 1 degree from the set temperature, then the humidifier is not active, because humidity and temperature are linked. Whenever the humidity is increased, the temperature will drop. So the Vitrobot always will first try to find or to set the right temperature, and then will increase the humidity to 100%. This increase in humidity will in most cases drop the temperature again, so the humidifier is then switched off, the temperature is increased again to the set temperature, and again the humidifier is switched on. And this routine is continued until an equilibrium state is reached. Most of the time you will be working at 4 or 20 degrees or anything in between, and then it only has a couple of bursts of water vapor to reach 100% humidity. We go to the Options tab and set the Vitrobot to standard settings this time. I'm normally starting, when I have an unknown sample, with a blot time of 2 seconds. A wait time I do not use, a drain time I also do not use. So those are both 0. Blot force I start in the middle, blot force 0, and a blot total of 1, I'll blot only once. I do not skip application. I'm using the foot pedal to go through the different steps. You can also use your hand, but I'm using my hands to hold the tweezers, so I rather use the foot pedal to continue to the next step. The humidifier is off during process, meaning that after blotting, the humidifier will not, like it does now, blow some water vapor in the chamber to keep it at 100%. I will also skip automatic grit transfer, I do that by hand. And the auto raise ethane lift I do not check, because I'm raising the ethane lift with the foot pedal. So to start, the rod will come down. For place new grit, we already see that the rod is down currently. So I'm now putting the ethane aside for a second, and I'm taking a grit and putting it on the tweezer. And I'm trying to grab the grit as far as possible to the outside, and I'm then bringing the clamp up to the first resist. So now the grit is locked. Also, I remember that the film is on the upside, and I'm right-handed, so I will be applying the sample on the right side. So that means that the film needs to face the right side. So therefore I'm putting, the film is on this side. I'm mounting the tweezers now on the rod like so. I then press the foot pedal for the next step, which brings the grit into the humidifying chamber. It now tells me to please place the ethane container. So I'm now taking the ethane container and placing it here. And I again press the foot pedal. And this brings the ethane container up to the humidifying chamber. The next step is starting of the process. So I can again press the foot pedal. This brings the grid down in the application position. I will now get a droplet of solution and I bring the pipette into the chamber. So when you apply a droplet to the grid, come with your pipette tip very close to the grid, but don't touch it. And what you can then do is you can push out a droplet from the tip, and then with this droplet touch the grid. And when the grid is properly hydrophilic and glow discharged, you can see there is a connection, and you can kind of move around your tip and apply the droplet to the grid. What you can appreciate is the contact angle that the grid and the droplet makes with the grid, indicating again that it's hydrophilic, so that contact angle needs to be significantly less than 90 degrees. Most of the time it's in the order of 45 or 30 degrees or lower, indicating that indeed the grid is hydrophilic and that the chances of getting a nice water film on your grid are high. Then the grid is raised between the two pads and the blotting process will start. The Vitrobot will blot and will shoot the grid into the liquid ethane. Because this ring is pushed down, then the nitrogen level is lower, so we can refill a little bit of nitrogen, the liquid on the side, and you can also pour vapor in the inside, and that will clean out the inside so that you can see a bit better what you're doing. Now we have to remove the tweezers from the plunging rod, and the way to do that is with one hand, the top hand, you're holding the plunging rod, and with the bottom hand you're removing the tweezers. You also have to make sure that the tweezers stay in the middle of the ethane cup. So to unlock it, that's it. I'm pushing the rod to the back a little bit and the tweezers to the front, and I'm now slowly removing the tweezers from the rod, and I stay with the tip of the tweezers in the ethane. I now will move the tweezers to the side and support the tweezers on the brass ethane cup so that I'm certain that I don't accidentally bump the grid into the walls. Also, my hands are high up. What you cannot do is push this ring down with your hand, especially with the hand that's holding the tweezers. So in order to have support and not have a hand floating in mid-air, I always use the side with my fingers. I'm holding the side, the right side of the ethane tray, so that I can keep this hand elevated and not push the anti-contaminator ring down. I then with my left hand move the whole assembly to a place where I can then continue. So by doing so, by holding this hand and resting my tweezers on the side of the brass cup and having on this side here my pink supporting the side of the tray, I can actually move anywhere I like while keeping the grid in the middle of the cup and not accidentally bumping it into the side of the bowl. So now that we've moved the tray to the side, we can release the grid. Now if we would release the grid by pulling the clamp back, the grid would fall in the liquid ethane. So what we have to do is we need to hold the tweezers tight to keep the grid in the tweezers, and then with the other hand, with this hand, take the clamp back and then switch hands again. And at the same time, we should not push this ring down because that is the anti-contaminator ring. So we have to keep this elevated. And the way to do it is to come in with your left hand and hold these tweezers tight. Then this finger will block the tweezers from moving anywhere, and we can then with the other two fingers pull the clamp to the back, which releases the tweezers, but the grid is still clamped by the left hand. Then our right hand is free, so we take over the right hand again and we can release the left hand. So now we have the tweezers clamped in with the right hand. I still have my hand elevated so that I don't push down the anti-contaminator ring. And I can still also support this grid on the side of the brass ring to make sure I'm not touching anything of the walls. And I can also rotate now easily the tray to align the storage boxes that I have placed here. Now to take the grid out of the ethane, you slowly lift it up and then you take it over the edge and to the side. Now it's very important, you don't have to be fast as long as you do not lift the grid too high up, because this anti-contaminator ring, the height of that also determines how cold it is inside. And the closer you are to the liquid nitrogen level, the colder it is. So make sure that when you go from the ethane cup down to the storage box, you do not lift the grid very high. If you lift the grid high like this, you have a large chance that it will devitrify. So make sure you don't have to be fast or in a rush. Just make sure you gently go over the edge to the side as low as you can go. Now there are people that also would like to remove some of the liquid ethane that might be sucked up by a capillary force in between the middle of the tweezers. The way to do this is to come with a piece of filter paper. You could pre-cool the filter paper in the liquid nitrogen, then lift the grid out of the ethane slowly, and while you're lifting the grid out of the ethane, you go with the filter paper along the tip of the tweezers down to the grid, removing that ethane, and then you move to the side and place it in one of the storage boxes. Once you have put all the grids in the storage box, you can then put a lid on it and move it to final storage. So you bring in the tool that has the lid and you pre-cool it on the side in the liquid nitrogen. And again, you know that when it's cold, when the light and frost effect has stopped, so when the sizzing is over, then the lid is cooled enough, and then you place it on the storage box, you turn it and screw the lid on. Once the lid is on, you can then move it to the side to a liquid nitrogen storage container. So for instance, if we have here the liquid nitrogen storage container, you would be able to quickly move that in there and then bring it to the microscope. Notice that when the ethane tray, the liquid nitrogen tray, comes up to the Vitrobot, it is not touching actually the bottom, but there is a space in between, and you can see in between there that the anti-contaminator ring is touching the bottom of the humidity chamber, but that these notches that stick out actually create a small space. So that's how it should be.